Good day, students. We are moving on to joint variation. Joint variation. When you talk of joint variation, you can have both direct variation and inverse variation in one question. So both of them can come together in a question. So when you have more than one type of variation in variation, that is, you are talking about joint variation. Now let's consider this question. A varies directly as B and inversely as the square of D. If A equals 3 over 4 when B is equal to 5 and D equals 2, find D when A equals 16 and B equals 27. Now, I've told you earlier that anytime you are given any problem on variation, you must always look for the formula that is connecting the variables. So now, you are told that A is directly proportional to B. So it varies directly as B, and inversely. You know, inverse variation talk of 1 over the square of D square. So that means if you say 1 over, if you're having A varies directly as B, then and inversely as 1 over D square. So you can still be saying A varies directly as B over D square. So this 1 over D square, same thing as B over D square. So that means A varies directly as B and inversely as D square. Then you are given the value for A to be 3 over 4 when B is equal to 5 and D is equal to 2. So you are going to substitute it into this. But before then, you must first of all remove this proportionality sign and introduce equality sign and a constant. So that means A should be equal to K. In place of the proportionality sign, put equality sign and a constant. K then times B over D square. A equals K times B over D square. So you now substitute the value of A, B, and D. So our A is 3 over 4 equals K times B is what? B is 5, while D is what? 2. 2 then square. So 3 over 4 is same thing, and 4 times 3, 12 plus 3 is 15 over 4 is equal to K times 5 is what? 5K over 2 square is what? 4. So from here you will cross multiply. So that means 15 times K, 15 times 4 should be equal to 5K times 4. 15 times 4 is what? 60 is equal to 5K times 4 is what? 20K. To get K, divide by the coefficient of K, which is what? 20. Divide both sides by 20. So 60 divided by 20 give us 3. 20 divided by 20 is 1 times K, which is meter. K is equal to 3. You now substitute this into this formula. So the formula connecting A, B, and D will be what? A equals 3, in place of K I'm putting 3, B over D square. Then after that, you can now solve the next question, which is find D when A is equal to 16 and B is equal to 27. So you are going to substitute. You are told that our A is what? 16. You put 16 is equal to 3 times B is what? 27 over D square. We are not given D. So you cross multiply. So when you cross multiply, 16 times D will give us 16 D square is equal to 3 times 27 is what? 81. So to get D square, you now divide both sides by the coefficient of D, which is 16. So D will cancel here, remaining what? D square. Then we have 81 divided by 16. So that one will give us a fraction. Then what we are looking for is not D square. You will now use this square to find the square root of the other side. So you move this square from this side, bring it to the other side. Whenever square crosses equality sign, it's now turned to a square root. Find the square root of this side, which is square root of 81 over 16. So the square root of 81 will give us 9. over square root of 16 will give us 4. 9 over 4. When you do this to mixed fraction, how many 4 and 9? We are having 2. It means that 1 over 4. Now, let's consider another question. So, we have the volume of the classroom varies jointly as the area of the floor and the height of the room. If the volume is 120 meter cube, when the area is 12 meter square and the height 5 meter, find 1. Equation of variation, and 2. Volume when area is equal to 80 meters square and height is 4 meters. So here we are told that the volume of the classroom varies jointly as the area of the floor and height of the room. It means that this is 2 direct variation. So that means we are decided it varies jointly as the area. If you take the volume to be V and you take area to be A and you take height to be H, so it means the volume varies directly as area and directly as height. So you can have 2 direct variation in one question, 2 inverse variation in one, or you can have the combination. It can be more than one. So now, if V varies directly as A and H, now for us to remove this proportionality sign, we are going to introduce a constant and equality sign. So V will be equal to K times AH. Now you are told that the volume is 120 meter cube when the area is 12 meter square and the height is 5 meter. So what you do is substitute the value for the volume, the area and the height into this. So when you substitute, for volume we have 120 is equal to K times area is 12 and times the height is 5. So 120 should be equal to K times 12 times 5 will give us 60K. To get K, you will divide both sides by 60. When you divide both sides by 60, so our K will now be what? 120 divided by 60 will give us 2. So our K is equal to 2. You now substitute these 2 into this formula you are having. V equals KAH. When you substitute it there, you have V is equal to 2AH. V is equal to 2AH. This is the formula connecting them together. So then the other part of the question says, find the volume when area is equal to 18 meters square and height equals 4 meters. So you now substitute the value of the area and the height into this to get the volume. Area is 18 and height is 4. So that V is equal to 2 times 18 times 4, which will give us 144. So it means the volume is 144 meter cube. So for the work practice, number 1, A varies jointly as B and C. If A equals 40 when B is equal to 2 and C equals 5, find B when A is equal to 9 and C is equal to 3. Number 2, P varies directly as Q and inversely as R. If P is equal to 8 when Q is equal to 2 and R is equal to 4, find P when Q is equal to 8 and R is equal to 1 over 2. Number 3, the mass of a solid shape varies jointly with the area of the base and its height. A solid shape with base area of 20 cm square and height of 8 cm has a mass of 240 grams. Calculate the mass of a similar shape with area of 25 cm square and height of 5 cm. Number 4, the mass of cement block varies jointly with the length and thickness of the block. A block of 22.5 cm in length and thickness is 12 cm has a mass of 810 grams. Find 1. The formula which connects mass, length and thickness. 2. the mass of a cement block of length 15 centimeter and thickness 12 centimeter. Make sure you like, subscribe and comment on this video. Thank you.